We're going to cover the fundamentals of network security using Google's built-in protection tools. Today you're going to hear from Susan Wu, who's a great outbound product manager that I get to work with on our network security products. My name's Peter Blum. I run a great team of product managers, some of who are here in the audience, and they cover the products that we're going to talk about today. And then we're super lucky to have Denis from our customer Wix. He came all the way out from Israel, 15-hour flight to join us, and he's going to talk about how Wix uses some of our technologies to protect their website. So I'm going to start by giving an overview of an example application. I'm going to use a complex multi-cloud application, and we'll use that throughout the session to talk about the different layers of defense that you can use to protect applications. I'm going to break this into two major scenarios. The first is around protecting services like a website or API that is exposed to the public internet. So we'll talk about the layers of protection that you get against the raw elements of the internet. Denis is then going to come up and talk about how Wix uses some of our products to protect them from DDoS attacks in their massive cloud service. And then Susan's going to come up and talk about the products that you can use to protect your application infrastructure. Things like the VMs, containers, serverless, and even services like BigQuery and Google Storage. And at the end, we'll leave some time for Q&A. There's a microphone over here, and so you can make a line there. We're also happy to stick around in the hallway to answer any questions you have, and there's a bunch of the PMs for the individual products here as well. So let's get started. So this is, I'm going to paint the picture of a complex multi-cloud application. I'm going to use a complex application, but everything that we're talking about scales down to even a single monolithic application in a single cloud pointing to internal users. But I wanted to use a complex case because it helps show you all the different layers of protection that you can deploy. So it all starts with users coming in from the public internet and services trying to access your APIs. They connect to something called a global front end that's responsible for delivering, scaling, and protecting your applications. Then there's a primary cloud assembly point. We generally find that someone picks the cloud that's going to be where most of the services are. And so I'll use that, of course, in Google Cloud for this example. But in that primary cloud assembly point, you're going to have a bunch of services. So maybe it's VMs. Increasingly, people are running this in containers and even serverless. And then in turn, those services are connecting to different public cloud services. So things like Vertex AI, BigQuery, even Google Cloud Storage. And so we'll talk about things that you can use to protect each one of those layers. And now it's very common that some of the services are running in other clouds. So that's the multi-cloud aspect. So for example, a product database. And then we see a lot of people incorporating SaaS services into their applications as well. And so a good example of this is SMS services, right? If you're going to send people text messages, you can hook into something like Twilio. So applications are getting big and complex, and one of the big things that we announced at the show in the keynote this morning, you saw TK, and we're going to talk about it more, is something called the cross-cloud network. And this allows you to really simplify the delivery, scaling, and protection of cross-cloud applications. And so we're going to focus on the protection aspects in this session, but tomorrow we have a drill-down session just on the cross-cloud network. It's the ARC 202 session. I invite you to come to that. We've got a lot of connectivity options as well that we'll talk about there. OK, so let's talk through the two usage scenarios. So I'm going to walk through the services that you'd use to protect an internet-facing service, so an API or a website that's facing the public internet. And that can be for using our global front end for services that are in our cloud, but it can also be applications that are in other clouds or even on-prem or in colos. And then Susan's going to come up and talk about the application or the products that you use to protect services that are in our cloud or across other clouds. So she'll come up after Denis. So the cross-cloud network covers both scenarios. With ML-powered protection, the highest threat efficacy of any public cloud, and we'll have a drill-down session right after this that's actually talking about some new announcements around that. And then lower total cost of ownership versus doing a per-cloud solution. So this session, as I said, is going to cover protection. But if you want to hear about the whole cross-cloud network story, you can come tomorrow to the ARC 202 session. Or we have a keynote for networking in the morning as well. So let's get into talking about protecting global application front ends. So serving applications and contents from different clouds in the past has required customers to build a complex multi-vendor front end. And you end up having different security controls, different ways of using the product, different features in each one. The cross-cloud network provides a simplified and unified solution. So it's built on top of our cloud network that's available in 200 countries around the world. It's backed by our own massive private backbone. And this is actually something we built originally to power YouTube, Maps, Search, and it powers the network for Google Cloud. So it has vast connectivity. We have our own private backbone. We have undersea cables. The amount of capacity on this thing boggles the mind. And then we have private interconnection points. So there's 187 places around the globe where you can actually interconnect your networks, your colo into our network, and you can get super fast, reliable performance. And then we have dedicated connections into other clouds like AWS and Azure. And then on the public side, we have massive peering with ISPs, so with over 1,000 ISPs around the world. So everybody wants to offload their YouTube traffic, and so we have massive interconnectivity with all the last mile networks, whether it's going to consumers or offices. And so this lets us provide a single global front-end service that can sit in front of apps in our cloud or other clouds and have great performance and connectivity. So now what I'd like to do is start talking through the layers of protection. I'll start at a high level, and then we'll keep drilling down. So first is Cloud DNS. This provides global public and private DNS resolution. So we have super fast performance and high scale. So that lets you soak up things like DNS-based DDoS attacks. Next up is Cloud Armor, which provides DDoS protection and a web application firewall. So this thing has blocked some of the biggest attacks on the internet. So we've got a great blog that Emil over here wrote that talks about, I think it was 46 million requests per second, all HTTPS traffic, and we were able to block that with Cloud Armor. And this covers both network and application-based attacks. Next is reCAPTCHA Enterprise, which helps protect against fraudulent activity and abuse, all without creating friction for the users. It's provided globally for apps. All of these things are provided globally for apps that are running in our cloud, other clouds, or even on-prem and colo. Now let's dig into each one of these in a little more detail. So Cloud DNS is our global managed DNS service that provides name resolution and DNS serving. It's deployed globally, and we use Anycast networking, which allows us to localize the requests from the users. So that means they get fast performance and high reliability. And with massive scalability, it can instantly handle legitimate spikes to your application, like a flash sale or a bunch of people coming in for a new release. But importantly, it can soak up massive DNS-based DDoS attacks as well. And you get a single solution across both public DNS services as well as private DNS within your cloud. Some of the recent innovations in Cloud DNS, we've made some DNS security improvements to protect against zones being poisoned in downstream resolvers using DNS cookies. And then Cloud DNS is now the default DNS service for GKE. When you're using our managed Kubernetes or Kubernetes service, then you can actually, it's just going to have Cloud DNS by default, and you can manage DNS through Kubernetes APIs and configuration. And then we recently introduced a multi-provider DNS solution that lets you synchronize DNS records across multiple providers. So you have reliability by using multiple DNS providers, and so it allows you to simplify operations but really improve reliability. Next up is Cloud Armor, which provides DDoS protection plus a web application firewall to protect your internet-facing services from both known and unknown attacks. So it has built-in rules for common attacks, things like SQL injection, cross-site scripting, Log4j, which we all remember from a couple years ago. And then it has an AI ML. So AI is big at the show. We've had our AI ML system for a couple years now. It'll model your traffic. In an hour, it'll learn traffic to your service, and then it'll start detecting unknown attacks. And it used to be that you had to go through and say OK and deploy a rule. I'll talk in a second about a new auto-deploy system. In addition to being able to protect web protocols, websites, web apps, APIs for mobile applications, Cloud Armor can also protect custom protocols. So things like anything with TCP or UDP protocol gaming services, VoIP services. We even have some customers that terminate their own HTTPS. They can run that through CloudArmor, and we can protect it. In addition to providing the service, we also have DDoS response services. So when you're under attack, you can pick up the phone or you can email us, and we'll help you during a DDoS attack. And we'll also provide DDoS fee protection. So if you incur a lot of networking charges during a big DDoS attack, we'll actually give you a credit back. Some of the most recent innovations around CloudArmor are custom rule creation for TCP and UDP-based applications. So this is for gaming and VoIP. We actually allow you to do byte matching on your own custom protocols, so it allows you to let just your protocol through and block the attacks. And then CloudArmor has been a global service for a number of years, ever since we released it. But we introduced at the show a new regional version of CloudArmor that's integrated into our regional web load balancer. And that allows you to keep configurations and telemetry within a certain area to meet sovereignty and compliance requirements, and also to allow for very high-end reliability scenarios. And then the last thing is auto-deploy. So I talked about adaptive protection, our AI/ML system. It used to be that you'd look and see the alert, and you'd say, yep, please go block it. And now we have a system where you can basically have us, as soon as we detect an issue, we'll automatically deploy the mitigation and block the traffic for you. Next up, I wanted to talk about a new CI/CD automation toolkit that we've released at the show that allows you to protect and deliver your internet applications more easily with our global front end. So this integrates CloudArmor, Cloud Load Balancer, and Cloud CDN with popular CI/CD platforms. So things like Jenkins, GitLab, and our own cloud build system. And it's an opinionated approach with best practices built in based on our experience deploying it with thousands of customers. And it's a toolkit, so you can use the whole thing, or you can just take Terraform pieces. You can take the pieces we use to integrate with Jenkins or GitLab. And it includes recommended settings across the products for delivering and protecting your web applications. It has pre-created workflows, so you can, within a couple minutes, you can spin up a whole global front-end stack. You can spin up one in development, one in staging, one in production. It lets you move settings. It lets you do rollback across those applications. And then we spent a lot of time on simplified workloads for things like canary deployment. So if you have a new version of your service, you can deploy it out into production, and you can give it just a little bit of traffic, test that everything's going okay, ramp up, or you can roll back if there's a problem. And so you can find a link to our GitHub with all the code and snippets that you can get there. The next thing is reCAPTCHA Enterprise. So this helps protect global front ends from fraud and abuse. It combines a global cloud service with code on the endpoint to help detect and stop fraud and abuse. It has an adaptive risk scoring system, so if you think someone's a little sketchy, you can send them a second factor authentication. If you know it's fraud or you know it's automation in use, you can just outright block them or redirect them to alternate content. And despite the name, it's frictionless, so nobody has to solve puzzles. It actually has code that runs either in a mobile app or in the browser to collect a bunch of signals and telemetry and figure out if it's fraudulent activity or a real human. And reCAPTCHA Enterprise is integrated with CloudArmor, so it makes it simple to deploy and take actions, things like blocking or redirecting to alternate content. We have some customers that block scraping attacks. They send them off with fake content, fake images and prices and things like that. So some of the recent innovations in reCAPTCHA Enterprise have been a mobile SDK, so you can actually integrate the client-side system to pull signals into Android and iOS applications, and it helps protect against a wider set of on-device fraud. And this complements the JavaScript code that runs in the browser for reCAPTCHA Enterprise. Account Defender, which helps protect against a wider range of account takeover attacks. Plus, it gives you the ability to trigger that multi-factor authentication if you're getting a higher risk score back. And now we can help protect against financial and credit fraud with detections for things like password leaks, so you can actually tell a user, hey, your password's been leaked, fraudulent credit cards, and even SMS fraud protection. So those are the products that help you protect your global internet front end. And with that, I'd like to hand it over to Denis from Wix to come talk about how they're using some of our products to protect their big service. Here you go, Denis.
Thank you. Hi. Shalom to everybody. My name is Denis Chertkov. I'm in charge of the DDoS protection solutions in the Wix networking group, part of the production infrastructure department. Wix is an Israeli company that provides cloud-based web development and hosting services. We allow our users to create websites with online drag and drop tools, even without deep knowledge in web. Wix audiences is several big categories, each of them represented by many different types of sites. Restaurants and bloggers, agencies and enterprise customers and more. Wix is one of the largest hosting services in the world. We have more than 200 million of registered users and the corresponding numbers of sites. I want to highlight the scale of the solution. So let's talk about protection. Each site can be attacked, and our client sites also. Since we support millions of sites, our infrastructure is constantly under attack. Most often, our clients' sites are under attack. But there are also attacks on our infrastructure, where sites are rendered and stored. Let's imagine the site, your site. To create protection rules for the site, you need to know traffic profile of the site. Minimum and maximum load, volumes and rates, some base lanes, geography of visitors, and a lot of different things. You can create profiles, you can create protection rules corresponding to well-known profiles of the site. It's not so trivial, but not a rocket science. And now imagine you have millions of different sites with different profiles of traffic for each of them. At Wix, we need to protect millions of sites with different loads, with different geography of visitors, all different. But each site or group of sites should be protected differently. It's not an easy task in itself, and DDoS attacks are growing last time. This is a challenge. How to protect millions of different sites with a high efficiency and without false positives. We tested several existing solutions, but got unsatisfactory results. And we decided to develop our own solution for detecting and mitigating DDoS attacks. DDoS protection itself, it's two big different things. First of all, we need to detect malicious requests, recognize attack, and generate actions or protection policies. Second part, we need to apply the policy to inbound traffic as close as possible to source of the attack, and so far as possible from our infrastructure. We have built an effective solution for detecting and mitigating DDoS attacks to our infrastructure and our client sites, but we wanted to improve it. Our DDoS detector worked fine, but we had several questions with filtering. Before Cloud Armor, we had several locations with in-house DDoS protection operating in different layers and environments. We have some questions with filtering, as I mentioned. Hard to manage and make changes because we didn't have a single endpoint for management. We used different systems, for example, for layer 3, 4, and layer 7 filtering, located in different places and different layers. Limited capacity problem. For example, if we have production bandwidth of 1 megabit per second, Then to protect against volumetric attacks, we need to have capacity 10 times larger. And the same situation we have with the web application firewall. We need only one for production, but we should have 10 and pay for 10. And we can't easily and simply increase our capacity. Sometimes it takes months, and we can only assume the size of attack in the future. It is also a problem of growth planning in terms of estimating capacity and costs. Due to those reasons, we started to use Cloud Armor protection. Why Cloud Armor? We have several advantages here. First of all, this is a centralized management. We have a single endpoint for layer 3, 4, and layer 7 filtering management with flexible and powerful rules. Because we have a single point for management, we can easily integrate it with our existing DOS detection system. Also, ability to grow and absorb bigger DDoS attacks. Cloud Armor has unlimited ISP and firewall capacity from our perspective. We don't need to think about increased capacity, about the capacity planning. Google think about it. Google has a good SLA with many points of presence. We can connect to the Google network in each DC or even use public internet for connectivity. Also, our clients have a lowest latency. Last but not least, it's a partnership. We already had successful cooperation in the past with the Google teams in other projects. As I mentioned, we have built an effective solution for detecting DOS attacks. And we can easily use it to manage Cloud Armor protection as a flexible, unlimited and powerful firewall on the edge of our network, as close as possible to the source of the DDoS attacks. On the diagram, you can see dynamic mitigation process of the DDoS. DOS detector analyze access logs, detect malicious requests, recognize attacks, and generate the actions. DOS enforcer performs the actions to Cloud Armor with Google API, and attack is mitigated by Cloud Armor protection. This process works constantly and constantly adjusts the protection rules according to the detected attack. If vector of the attack will be changed, or new attack will be created, it will be also mitigating during the next iteration of the process. This approach allows us to build powerful, resilient, and flexible DDoS protection solutions. This is an example. Example probably largest attack last year. On the top picture, you see the graph of the blocked requests by Cloud Armor side. On the bottom, a graph of the request passed to our backend after the filtering at the same time frame. There are no any deviation on the bottom graph because DDoS was blocked on the Cloud Armor side without any negative impact to our backend. There are no any digits on the bottom graph, but it was a very large attack, millions of requests per second. The described approach has proven its effectiveness in practice. It's not just a theory, it works. What we already achieved. We are sleeping better at night, it's very important. We block in automatic mode big DDoS attacks without negative impact to our backend and to our clients. We decrease the amount of requests passed to our backend and save money, a lot of money, because we don't need to scale up our backend during the DDoS attacks now. Despite the increased volume and frequency of DDoS attacks, we don't need to change our infrastructure often because we have no any capacity issues now. And we have a platform, with those remediation systems that allow us to improve and develop the mitigation system in the future. About the future. Every protection, it's an endless battle, and we want to improve it. We plan to reduce the time from detection to mitigation of the attack. We think how to improve our detection algorithms using AI. We want to create dashboards with the saved money, not only with the passed and blocked requests. And we are developing our system to protect the infrastructure from new types of attacks in the future. I would be happy to share some practice examples, but I hope you all understand why I didn't do it. I tried to share principles and approaches how to build an effective and reliable DDoS protection solutions. I hope it will be helpful for you. That's all. Thank you very much for your attention.
Hi, everybody. I'm here to talk about how to protect that multi-app infrastructure. So organizations are building these distributed apps, and they're spanning more than one cloud, and they're assembling the best-suited components and managed services across these cloud providers. What you get, app owners benefit with this feature velocity and time to market, but at the same time, it introduces some security concerns for the organization. And so that's why we're offering this multi-layered security approach to protect the application and the infrastructure underneath the application. Starting with Cloud Firewall. We have Faye in the audience. She's the product manager for Cloud Firewall. So this is evolving to the Cloud Next-Gen Firewall. So this is comprised of Cloud Firewall and intrusion detection. This is built into the Google Cloud Fabric, and it provides the protection for perimeter and workloads with the leading threat intelligence from Palo Alto and the threat intel from Mandiant, Google Mandiant. Let me add the next one. The next layer of protection is called the Cloud Secure Web Proxy. So this monitors and provides monitoring and securing the web egress traffic. We also have a PM. He might be in this audience. Naveen, if you're there. Anyway, if you have questions for Naveen and Faye, feel free to come through. And so this protects your workloads that access the SaaS and internet. The next one, the next layer of protection is the Cloud NAT. Is this right? Let me see if this is correct. Okay. So this is the Managed Network Address Translation Service. I have the PM for Cloud NAT here, Udit. Sorry to draw your attention, but it's all fun and games here. So Cloud NAT provides that Managed Network Address Translation Service. And for traffic that's traversing, going out to the internet, and for between the VPCs, this makes network access very private and simple. Next up, we have VPC Service Control. So this provides a virtual perimeter around your Google services and helps to prevent the data exfiltration by attackers. So that's a very common technique by ransomware and attackers. Lastly, we have a GKE network policy. So this provides a comprehensive security protection for your GKE workloads. So first, using that Cloud Firewall that we talked about and the secure web proxy to control and protect the traffic that's going in and out of the clusters. And then lastly, we've also enhanced the network policy in Kubernetes to provide additional controls for your workloads. So let me spend a little bit of time to talk about that first layer of protection, which is that cloud NG firewall. So this layer of protection is protects your workloads, cloud workloads, but it provides that operational simplicity. So I mentioned this is built by Google Cloud, and this protects that, provides that threat protection for both intrusion detection, IDS, and IPS, intrusion prevention. And this is enabled by the threat technologies from Palo Alto and with the threat intel from Google Mandiant. So this is a distributed firewall. This is built into the Google fabric, and it provides us simplicity, scale, and coverage of both the perimeter and the workloads, all without network changes, all without routing changes. So security follows the workload. So Cloud NG Firewall provides that unique hierarchical firewall policies that can be applied organizationally wide. So it could be applied globally across your network and application layers, and it provides a consistent network security policy control for you. So there's some innovations that we put in this Cloud NG Firewall. I talked about IDS and IPS. So this has through the work of a third-party tooling, we were able to demonstrate high efficacy for this solution, meaning the cloud firewall has shown that it can has a high efficacy across all threat severity levels. It has the ability to block attacks against vulnerabilities. It could be malware, it could be command and control. And again, I mentioned it's from Palo Alto, based on Palo Alto technologies. And it works on encrypted and unencrypted traffic. Another additional feature is the ability to provide the geo and threat intel and FQDN policies. So these additional controls can block or allow traffic based on the country or based on the threat intel from the Google Mandiant. So this is along with the controls with the fully qualified domain name. The last feature innovation that we have in Cloud NG Firewall is this is a unified policy for perimeter and workloads across layer 3, 4, and 7. It's based on the IAM-backed org-wide tags. So it means that because it's a tag-based system, you have instantaneous control over any infected systems. So that is also released. Let me see. We also have a session. Please come by right after to see this Cloud NG Firewall session. It is at 4 p.m. right after this one. Please join us. So the next layer of protection comes from Cloud Secure Web Proxy, as I mentioned. So it monitors and secures the egress. It ensures that your cloud workloads do not connect to, say, unknown destination. Why is this important? So customers were telling us that they don't want to send data to maybe some unknown destinations, maybe because due to some misconfiguration error that they made. So the 4 main reasons for using Cloud Secure Web Proxy is you protect this traffic with a native service. Instead of using a VM and maybe putting the security controls into a VM, so this is a native service. And it protects that cloud workload from these malicious activities. So it inspects the web traffic, and then it blocks the untrusted access. And it's easy to deploy because it's a managed service, and it scales because it's a managed service, and it automatically updates as well. So this is very effective if you're implementing kind of like a zero trust principle. So this could give you the granular controls over the web traffic. Additionally, every HTTPS is logged, and so that this could be used for compliance use cases. So meaning this could allow you to monitor your usage, discover and disrupt any threats that's happening in the network. You can spot command and control traffic or any malicious data transfers. So if the auditors show up at your door, you can say that you have implemented the controls because you have all the logs to prove that. And let me show you some of the latest features that are latest innovations in Cloud Secure Web Proxy. So what's been added is there's a granular egress access policies. So this limits the traffic based on the source, identities, and identities could be tags or service accounts, destinations, HTTP types, headers, et cetera. And then in the second set of innovations is support for TLS inspection, so meaning you can intercept the TLS traffic, and then you monitor and enforce the policies. And this is also integrated with a certificate manager, so you could have certificates that's used with the TLS inspection. CloudNet. It's an audience. So CloudNet is a managed network address translation service. So meaning some of the resources may not have external IPs, but using CloudNet, you can create these outbound connections to access the internet, and you can use them in between VPCs. So this works in line with Cloud Firewall. There are two main use cases for CloudNet. So maybe some of the workloads you don't want to expose to the internet. So this is one use case. The second use case is you might have a group of VMs, and you maybe only want to expose one public IP address for the whole group. And so this would allow you to have these NATed traffic for the whole group, and then NAT to on-prem. So CloudNet is built also on Google's distributed cloud fabric, and it simplifies this configuration operations, all without forwarding, routing changes. CloudNet actually works with a variety of workloads. For example, it could be VM instances without the external IP. It could be the private GKE clusters. It could be Cloud Run. It could be Cloud Function, App Engine instances that you want to expose through the serverless VPC. So there's some innovations for CloudNet that's coming around. So the big one is NAT for standard tier, meaning you can use now CloudNet to support the standard tier networking egress traffic. And now you can also mix and match between your premium and standard using the same NAT gateway. The second innovation is also in preview, is the private VPC, private inter-VPC NAT. So meaning you can have private IP translation for the communications between two overlapping private IP resources. And they could be in different VPCs or even in different cross regions. So those are the innovations for CloudNet. VPC, let me show you another layer of security controls. So VPC security control is actually for Google Cloud Services, and it prevents the data exfiltration. It isolates the services, so it makes it difficult to extract data. So for example, the sensitive data can only be accessed through these authorized networks. And so this will provide you with the granular controls for, say, between your on-prem and your other environments, and meaning all unauthorized networks are blocked. And this works, these operations, this helps with the cloud security operations because you can now restrict your Google service APIs based on, say, identities or geos, and maybe based on trusted clients. So this is just another layer of security control. We have additional innovations for this product. So there's 2 to 10 times improvement in scale. And the other one is there's a private address support, which is in preview. So you can use these private addressing in VPC service control. And again, this would provide you more granular control over different environments, say, between on-prem and to other environments. So that one is in preview. Again, we also have a great session for VPC service control. This is in August 30th, which is tomorrow, again, 3:30 p.m. The session number is security 213. Visit the session and hear from the other areas, other product managers. So GKE, one of the very, very intriguing things, how many folks are running GKE in the audience? Just curious. Oh, very, very awesome. So GKE, we offer this comprehensive layered security for GKE workloads. So we have both cloud firewall and cloud secure web proxy to protect the ingress and egress traffic coming in and out of the clusters. And then we enhance the Kubernetes network policy that's already providing the namespace isolation. So I spoke a lot about the cloud firewall earlier. In GKE, we actually have full lifecycle management of cloud firewall. So including protecting the pods and the communication, you actually don't have to do anything. It's complete full lifecycle management. For just typically an upstream Kubernetes, the general best practice is kind of to deny all traffic to the pods, and then you can use the concept of labels. Say maybe everything it labeled project A, all the pods in project A can talk to each other, or you might do something with namespaces, like all the pods in namespace blue can talk to each other, all the namespace red won't be able to talk to each other. So in this case, in GKE, what we have done is we enhanced the network policy, enhanced it with the metadata, and we added logging to the cloud, the network policies. And then we also added additional innovations. Let me talk to the Kubernetes policy logging in particular. So troubleshooting network policies is kind of a lot easier based on what we have done. So what we have done is we kept a record of all the network policies, and then we actually uploaded all of these logs into cloud logging. So that's an innovation that we have done to enhance upstream Kubernetes. And the other thing that we have done is we added this flexible FQDN matching conditions. So what we're doing is we're limiting the egress traffic, and meaning you could look at the picture. So all the ones in, let's say the operator defined that the ones in namespace blue can talk to the egress traffic. And so what we have done is we've added both the FQDN for both the host name and the domain name, so which it makes it possible for us to protect the GKE workloads from accessing the unwanted domains. So in the picture, all the pods in the red, those are not accessible, because they're in the namespace red. So those are the things that we have done for GKE. Both of them are released, but for FQDN, that's in preview. So now let me bring Peter back up to put everything together. Thank you.
So just to wrap up, hopefully you've seen we've got a broad set of layered solutions that allow you first to protect the global front end from internet-facing attacks, right? You've got Cloud DNS for high-scale DNS and DDoS protection, Cloud Armor for network and application layer DDoS protection, Recaptcha Enterprise for bot fraud protection, and then Susan just took us through all the solutions that you have for protecting the application infrastructure in our cloud and multi-cloud. Firewall and IDS, along with the great new stuff we're announcing at the show, really the evolution to Cloud Next-Gen Firewall with the Palo Alto Networks technology. Cloud NAT for network privacy, Cloud SWIP for egress web and egress traffic to other clouds, and then VPC service controls. So with that, we'll stick around afterwards if you're not feeling like asking a question in front of the whole audience.